Learn more on BBC Bitesize.
Have you ever wondered how your takeaway hot drinks stay hot, or how some takeaway cups are less effective? Let's look at thermal insulation.
Yeah, all right. Now, thermal insulation is essential for reducing heat transfer in all sorts of places. For example, between the interior and exterior of buildings, and in insulated cups and drinks flasks. All right, now insulators work in two main ways. They keep things hot by reducing heat loss from a hot object, and they keep things cool by reducing heat transfer to a cold object from its surrounding.
We're going to test the thermal conductivity of different materials to check their effectiveness at reducing heat loss or gain. Materials with high thermal conductivity have a high energy transfer rate, so they are poor insulators. If they have a low conductivity, they are effective insulators. Now, for this experiment, you're going to need the following things. Do pause and take a look. Now, don't sit down to perform this experiment, just in case you spill the hot water.
All right, so the control variables are the ones that we keep the same. So that's the volume of water, the starting temperature of the water, and the thickness of insulating material. So
Let's get started. We need 80 cubic centimetres of hot water.
Okay, so that's about here.
So I'm going to transfer that into this smaller beaker. Now this is our constant volume of hot water. Now for the control, we're just going to put that into the beaker with no insulation. Oops, there we go.
There we go.
But I want to put this on top and then the thermometer so we can measure the temperature. Now as I put this in, we'll measure we're at the right temperature. To achieve a consistent starting temperature, we will wait until the temperature drops to 70 degrees C before starting the experiment. When that's ready, we're going to start our stopwatch and record the temperature of the water every 2 minutes for 10 minutes. That's 70, and start the stop clock.
All right, so where are we at?
Okay, so we've got another 2 minutes, so I'll take another reading. What have we got now? Try and keep it in the water. Okay, yeah. Lovely. Got another 2 minutes.
Another 2 minutes to go. Now we're going to repeat the experiment, but we're going to add our first insulating material. We'll insert it between the two beakers like this.
I need to get the lid on again. The thermometer. And start the stop clock.
Next, we'll repeat the experiment with cotton wool and finally bubble wrap.
After recording our results, we're going to plot our cooling curves, which is the temperature in degrees Celsius on the y-axis against the time in minutes on the x-axis. The water will cool down at the slowest rate with the most effective insulator. We can see on our graph that this has the shallowest gradient, therefore has the lowest rate of energy transfer. In this case, it looks like it was the cotton wool. This has the lowest thermal conductivity of all the materials.
Now, most insulators work by trapping a layer of air. The thermal conductivity of air is low as long as it's not free to move. So the more that we can trap within our insulator, the less heat transfer will occur.
Insulators reduce heat transfer between objects or places which are at different temperatures. The higher the final line position, the more effective the insulator.
For in-depth GCSE resources and practice, visit BBC Bitesize now.